Go, go, go.
Hello, everybody. We're going to be working on limits again. So what I would like you to do is to do the try this, which is to find the limit as x approaches -3 of this function here. I want you to find the limit by filling in the table below. So here's your x's. Plug in your x values to get your y values that'll plug into each one of these boxes. Okay, so put me on pause and do that. Okay, so when we plug in -3.01, we get -5.01. When we plug in -3.001, we get -5.001. When we plug in -3.001, we get -5.0001. Now, when we plug in -3, we get an undefined. When we plug in -2.9999, we get -4.9999. When we plug in -2.999, we get -4.999. And when we plug in -2.99, we get -4.99. So you can see that my x values here on the left were approaching -3. And my y values, right, are getting closer and closer and closer to -5. And coming in from the right side of -3, as my x's are getting closer and closer to -3, my y values are getting closer and closer to -5. So my limit as x approaches -3 is -5. But however, when I do a direct substitution, if I plug in -3 here into the denominator, you will see we will get a 0. That's why it's undefined. But obviously there's a limit because as x approaches -3, my y approaches -5. All right, so let's write this down here. As x approaches -3, f of x approaches -5, right? So my limit is -5. However, when I do the limit, like how I told you earlier last week, when we do the limit by substitution, right, when we plug in -3 into the denominator, right, I get an undefined because it'll be -3 plus 3, which is 0. So that's undefined with direct substitution, but the limit is actually -5. So we have to come up with a way to figure out what the limit is if, when I do direct substitution, I'm getting an undefined. So this is called the dividing out technique. So when you find a limit, you should always do direct substitution first. And if you get an undefined, if you get a 0 in the denominator, then you have to go to either this technique or the technique that I'm going to show you in a couple of days. All right, so the first thing you're going to do is you're going to factor completely. So you're going to factor the numerator and denominator. You're going to reduce. You're going to rewrite the limit. So you're going to write it with your new equation, your new function. And then you're going to find the limit with direct substitution. All right, so number one, sorry, I just wrote over that. Number one is from the do now. So I'm just going to move everything up a little bit. Okay, so I notice here that I have x squared plus x minus 6 over x minus 3. The numerator can be factored. So the numerator factors and becomes x plus 3 times x minus 2, and that's over x plus 3. So you probably kind of remember this a little bit when we graphed rational functions. Remember when I factor and I can reduce, right? These reduce to 1 and 1. That means there's a hole in the graph at x equals -3. Remember doing that? So what I'm left with is x minus 2. So now you're going to rewrite the limit. So you rewrite it as the limit as x approaches negative 3, and then you use this guy here, of x minus 2. Now you're going to do direct substitution. So I'll just do the work down here. So I have negative 3 minus 2 is negative 5. So the limit as x approaches negative 3 of x minus 2 is negative 5. That's like what we got in the do now when we did substitution in the chart. All right, so let's take a look at number 2. All right, so the first thing we're going to do, because I just said before, is you always try direct substitution first. All right, so when I do direct substitution, right, I have the limit as x approaches 1, so it's 1 minus 1 over 1 cubed minus 1 squared plus 1 minus 1. So I get 0 over 0 actually. So that's undefined. Okay, so we can't do direct substitution. So we need to factor and see what we can reduce out. All right, so I notice the numerator is going to just stay x minus 1. The denominator, I see that there are 4 terms, so I'm going to factor by grouping. So the first group GCF is x squared times x minus 1. The second group, the GCF is 1 times x minus 1. So my factors are x squared plus 1 and x minus 1. So I see that x minus 1 and x minus 1 reduced to 1 and 1, which means there's a whole at x equals 1. So I'm left with, be careful, it's 1 over x squared plus 1. So now we rewrite the limit. So we write it now as the limit as x approaches 1 of 1 over x squared plus 1. So now I'm going to do direct substitution and plug in 1. So I have 1 over 1 squared plus 1. So that's 1 over 1 plus 1, which is 1 over 2. So the limit as x approaches 1 is 1/2. Okay, so that's it. Pretty simple. So you're going to do some practice for the next couple days, and then we'll get to the last technique. All right, everybody have a good day. Stay well.